All right, AP Stats, we are looking at example 10, mortality. How exciting. All right, so we have death records that are examined at a local hospital for 1,000 randomly selected deceased patients. So you can tell right away that this is an example using a table. And if you will notice in the table, I've got my total right here. It's all 1,000 of my people. All right, so I'm just going to jump right in here and talk to you about the fact that up here in the top we have causes of death. We have cancer and we have heart disease. And then over here on the left we have some people who were smokers and some people who were non-smokers. So we're going to study this table. I'm going to highlight my totals. Oh, and also I didn't talk about this. There's the causes of death. There's an other category as well. So if you will look, our totals are right here. Okay. So we're going to go ahead and start on the problem. What is the probability a patient A died of heart disease? Remember, okay, some of you are going to look at heart disease right here, and you're going to say 465. All right, but I'm looking for the probability. Okay, so keep that in mind. I'm not looking for a count. I'm looking for a value between 0 and 1. So the people who died of heart disease total are 465 out of 1,000. Just like that, you can leave it. Don't do anything else to it. You don't need to. All right, B, what is the probability that a patient did not die of cancer? Okay, so I'm going to not look at the people who died of cancer. I'm going to focus on the heart disease people and the other category. These are the people who did not die of cancer. So the probability that a single patient did not die of cancer is 465 over 1,000, or they died from other. So I'm going to add these together, and that is your answer. All right, C, what's the probability that a patient was a smoker and died of cancer? Okay, and is going to be an intersection in your table. That's what and is. That is an intersection. So what I'm going to do is find the intersection of being a smoker and died of cancer. So that is going to be, here's cancer right here, okay, that's this column, and smokers row is this one. So I'm looking at that 135 out of 1,000. That's how I do that. All right, part D. What's the probability that a patient was a smoker or died of cancer? Okay, you have to consider those who smoke or died of cancer. So all of the smokers are 650 people, and all of the cancer deaths are 190. Okay, you have to be careful here. This is what I was talking about in the table video about overlap, because the people who died of cancer are all of these people, and the people who smoke are all of these people. There is overlap right here at 135. We do not want to count that twice. So what I can do is I can think of it this way. 650 people are smokers, and I've got 190 people that died of cancer. I am going to subtract 135 from this total because I don't want to count it twice, and right now I am. When I'm looking at all of these people, 650, and all of these people, 190 cancer, I'm counting 135 twice. So I don't want to do that. So I've got to subtract one of the 135s out of here. And this gives me 705 over 1,000. Now, you can also think of it this way if it makes you more comfortable. You can count this whole row of 650 and then just add the 55 to it. Okay, and then you don't have to subtract 135. You still get the same thing. All right, E, what is the probability that a patient, oh, sorry, I was thinking the original part of the problem. Are being a smoker and dying of cancer independent? Well, we haven't talked about independence yet, so we will revisit this in another example.